Welcome to the Provenance Lab and this tutorial on solving NLP tests for provenance texts. According to the AAM guidelines, provenance texts are delimited by punctuation marks, as explained in our video tutorial on reading and writing provenance for those of you that have yet to watch it. The first step of extracting knowledge from a provenance text involves dividing the text into separate sentences. Luckily, there is an NLP task that can help us to do just that. It's called Sentence Boundary Disambiguation, or SBD for short. The goal of this task is to divide text into sentences. The only problem is, provenance texts are quite peculiar when it comes to delimiting sentences, divided as they are by both periods and semicolons. Moreover, punctuation marks in provenance texts can often be ambiguous. For example, a period after an abbreviation does not always signify the end of a sentence. For this reason, we here at the Provenance Lab apply deep learning models to address such ambiguities. By annotating sentence boundaries, we train deep learning models to disambiguate punctuation and thereby divide provenance texts into separate events. But what does disambiguation mean exactly? Disambiguation means automatically detecting whether the period after the letter C in the following provenance event is an abbreviation of circa, say, rather than the end of a sentence. In the following provenance text, then, deep learning models can differentiate between all those punctuation marks that signify sentence boundaries, here highlighted in green, and all those ambiguous punctuation marks that don't in fact divide a sentence, here highlighted in red. And it is only once we have divided provenance texts into individual events through SBD that we can start to extract knowledge from them. To do this, we need to apply another NLP task called Span Categorization. The goal of this task is to identify and classify portions of text, otherwise known as spans. Here at the Provenance Lab, we have created a set of categories to help identify different spans in provenance texts, from methods of transfer to the parties involved. Let's take our previous example, Gift 1973 to NGA. Since the word gift represents a method of transfer, we have assigned it the span category of method. Then there is the question of when the event occurred, here 1973, to which we have assigned the span category time. Finally, to the acronym NGA, which represents the party acting in the event, we have assigned the span category of party. But that's not all, for we are not limited to a number of categories and can assign more than one to the same portion of text. Take, for example, the acronym NGA. We can also assign the categories of name, receiver, and group, since it concerns not only the name of the party involved, but also the party receiving the object and an organization, respectively. Of course, none of the above happens like magic. As with everything in artificial intelligence, machines are nothing without human intervention. And training intelligence doesn't exactly happen at the click of a mouse. In order for deep learning models to in turn assign multiple categories to a portion of text, we must ultimately feed the machine a number of examples of provenance events involving different categories. Take the categories of sender and receiver, say. We would need to feed the machine enough examples of provenance events involving senders and receivers for it not to mistake the two. After all, we wouldn't want to make a perpetrator of a victim and vice versa, for that's all in the job of a provenance researcher. Which brings us to our next tutorial on keeping the expert in the loop at the Provenance Lab.